Hello Year 8 and welcome back to Mathematics. In today's lesson we're continuing with our topic of measurement and we're going to be looking at the volume of a few further shapes. So last lesson we started talking about what volume was. The volume was the space inside a 3D shape. What we're going to be talking about is actually calculating the volume for not just rectangular prisms, which we looked at last lessons, but any prism in general. So, if you have a look at today's learning intention and success criteria, what we want to be able to do by the end of today's lesson is to calculate the volume of prisms and cylinders. We want to be able to firstly identify the formulae for prisms, find the volume of prisms, and calculate the volume for cylinders as well. So let's get started in today's lesson. So first of all, we need to talk about what a prism is. Now last lesson I talked about a rectangular prism, and I kind of briefly introduced this concept of what a prism is, but here we're going to need to talk about what a prism is more generally. Now, a prism is a 3D shape which has a constant cross-section. What this means, this is where a 3D shape has two ends with the same shape and all other sides made of rectangles. So, constant cross-section. What this basically means is that on all prisms, there's going to be two sides which have the exact same shape. And along the whole way of the prism, between those two faces, you can basically cut up at any particular point along your prism and you will get that shape as off the face that you cut off. So for example, here on the left hand side, we have this shape over here. We call this a triangular prism. Well, we name prisms by the base shape. So this is a triangular prism. So if you have a look at this triangular prism, on two ends, I have this exact same triangle. And so all the way in between, so the exact same triangle, and all the other faces, they all happen to be rectangles. So that's an additional thing to notice. All of these other shapes that are in between our two triangles, they are all rectangles. But the other thing to notice is that it has this constant cross-section. So if I was to cut this triangle at any particular point, so let's say I was to cut it along here. So cutting it along here, what would happen is I would end up getting, if I cut it open here, along that way, what we would notice is that it would create a triangle which is the exact same shape as the other two triangles on the other end. So that's what it means for a shape to be a prism. Now we've got a few other examples. In the middle here, we have the prism that we looked at last lesson. This is our rectangular prism. And so here, the thing about a rectangular prism is that no matter which way you look at it, you actually got a whole bunch of base shapes. So here, notice here, you've got this rectangle is exactly the same as this rectangle over here. And so if you cut along anywhere along in between those two, so let's say I cut along here, I'm actually going to get that exact same rectangle, if I drew this correctly, in the middle here as well. But as you notice with the rectangular prism, we can actually rotate it and we can say that, oh, actually, instead of having those two as my base shape, I could cross-sectional shape, I could also have this shape and the shape at the back. So these two have the exact same shape as well. And if I cut away along anywhere in between, so let's say along here, what you'll notice is that I have the exact same rectangle as well. And so here, with a rectangular prism, it's actually a special case where it doesn't matter which way you look at it, you're actually going to get that same rectangular base shape. Any way you look at it, you can have a cross-section, you can have one of those one of those two end shapes any way you look at it. And the third example that I have over here, this is a if you have a look, we've got two shapes which are exactly the same on either end. So this one over here, and this one over here. And if you have a look at what the shapes are, these have 6 sides, which means they are a hexagon. So this is a hexagonal prism. And if we were to cut along anywhere in between those two hexagons, so let's say over here, for example, I cut along over here, cut along there, it would actually make that hexagonal shape, which is exactly the same as the one at the top and the one at the bottom. And so that's what a prism is. It has a constant cross-section. That shape is the same along the whole way along between the two end shapes. So that's what it means for it to have a constant cross-section. Now, we need to talk about how to actually find the volume of a prism, a prism. Now, last lesson we went through this formula for a rectangular prism, L times B times H. And so what we did here was we just multiplied the three dimensions of a rectangular prism. However, if we're talking about a prism more generally, any prism, any type of prism, they follow the same volume formula. And the volume formula looks like this. V is equal to A times H. A times H. Or in shorthand, we would write this as AH. Now, what are these two, A and H? What do they refer to? Well, let's start off with A. A is just the cross-section area. So this is the area of the cross-section shape. So what we would basically do, or another way of thinking of this, is the area of the base shape. So this A here is just finding the area of this base shape. So for example, in this triangular prism, we would be finding the area of this triangle. With our hexagonal prism, we would be finding the area of this hexagon. And with a rectangular prism, it actually is a little bit different, because you actually could pick any three of our faces to be a rectangle, the base shape. So we could actually pick this side if we wanted. We could also pick this side if we wanted. So here, the A just represents the area of that cross-section shape, which shape is on the two ends of our prism. Then we've got this H over here. Now H is actually short for height, but the way I like to think of it is this is a height, perpendicular height, so this is the height between the two ends. Oh, let me try that again. So, if you have a look back at our prisms, what we're looking here is just what's the distance between those two end shapes. So here, the height for my triangular prism would be from over here to here. So this would be height. In the middle one, the rectangular prism, this one, it'd just be this measurement here, this height over here. That's our height, because we're starting with this front face. However, if it was the other way, so if I picked, for example, this shape, this rectangle, the height would actually be, well, this length over here, because it's how far it is from that end shape to the other end shape, which is exactly the same. And for our hexagonal prism, our height happens to be just this measurement here. How far is it from that top hexagon to the one at the bottom? Okay, so that is our volume formula for a prism, A times H. So when we're trying to find the volume of a 3D shape, what we want to actually do, there's a few steps that I have identified here. So firstly, we want to identify what the cross-section shape is. Identify what the cross-section shape is. What shape is at the top, at two ends of your prism, and is just going to create that cross-section along your prism. The next part is to calculate the area of the cross-section shape. So you want to go and find that area of that particular shape, that using the area formulas that we actually looked at. So in this topic, we've actually gone through a whole bunch of different area formulas already, and you're going to need to, in most of the questions, you're going to need to actually apply one of those formulas. So for example, you might need to use the fact that a triangular prism, so a triangle, we had to use A is equal to half BH. With a rectangle, we actually did that one. A is equal to LB, and there was a few other shapes that we also had a look at as well. Then the final step is to multiply the area by the perpendicular height of the prism. So we just want to find that height, like over here, that height value, and just multiply that area with that height. So let's have a go at a couple of examples of this. First one over here. So here we want to find the volume of the following shapes. So let's have a look at this first one over here. I have this particular shape. It is a prism. So here, if you have a look, I'm just going to turn this off. If you have a look, here we've got this shape where we've got a cross-sectional area over here, and if you have a look, the shape at the bottom is exactly the same as the shape at the top. They're exactly the same. So those are going to be my two end shapes in the area of my cross section. So here, I'm going to write is volume is equal to AH. First of all, actually, even before we begin, we should be writing our formula first. What I want to do is find that area of that particular shape. Luckily for us, they've actually given that to us. They tell us that that is 10 centimeters squared. So I'm going to write here, that's going to be 10 times, well, the height is just the length or the distance between the two of them. And so here, they tell me that the height between the two of them is 3 centimeters. So I'm going to multiply that by 3. So here, I'm going to get 30. And just like we've been looking at last lesson, volume is measured in cubic units. So this is going to be 30 cubic centimeters because all of these measurements are in centimeters. So when we're trying to find the volume, all we need to do is find the area of the cross-sectional shape and then multiply it by the height. Let's have a look at the next example. Here, B. Now this time we have a triangular prism. Now if you have a look, my shape, we have a triangle on this end and a triangle on this end. And so here, even though they don't look quite the same, that's okay. We've got a triangle on this end and a triangle on that end. So those are my cross-sectional shape. So here, that is my, this guy here, we're going to find the area of this particular shape. Now the area formula for a triangle is half base times height. And so I need to actually find the volume of that the area of that particular shape first. So here I'm going to write the formula for the volume. V is equal to AH. So let's find the volume area of our triangle. If you remember, that is just half times base times height. And if you have a look at my triangle, I've got my base length of 4 and I've got my height of 2. And so for my area, I'm going to do half times 2 times 4. So that's for finding the area of my triangle. So when I'm trying to find the area of a triangle, I use this formula, half base times height. And so that was going to, so for my particular triangle, I've got 4 centimeters for my base. I've got 2 centimeters for my height. Then in the volume formula, we need to actually multiply that by the height. So what's the distance between the two triangles? And if you have a look at this particular shape, the distance between those two triangles is this 8 meters here. So I'm going to multiply this whole thing by 8. Okay, so let's actually calculate this. Half times 2 gives me 1. 1 times 4 is 4. 4 times 8 gives me 32. So this is 32 meters cubed. So for this particular example, we actually need to find the area of my triangles first before I actually calculated the volume. So here I found the area of the area of my triangle by using that formula half BH. Then we had to multiply it by the height, the distance between those two end shapes. Okay, let's have a look at one final example. Oh, I don't have. There isn't one. Never mind. All good. Okay. So that's how we find the volume of a prism. We find the area of the two, the cross-section shape, then we multiply it by the height that is between those two shapes. So that's finding the volume of a 3D shape, or 3D prism. Volume is equal to A times H. We're going to use this formula when we do that. Now, there's a very specific case of a prism, which is when the cross-section area is a circle. And so here, that's a cylinder. Now, a cylinder is a prism where the cross-section shape is a circle. So a cylinder is just a special case of a prism. And so when we're dealing with cylinders, what we need to do is we need to remember how to calculate the area of a circle. Now, in this topic, we actually looked at finding the area of a circle. And here I've pulled out that formula from that lesson. When we're trying to find the area of a circle, we need to use this formula, A is equal to pi times r squared. A is equal to pi r squared. And so here, there's a few things we need to notice. First of all, we need to make sure that we have the radius measurement and not the diameter. And if we have the diameter, we can actually convert between the two. So we can take the radius is just half of the diameter and just put it into this formula pi. And we need our calculators out for this particular measurement, where we press shift times 10 to the power x, where we get this pi button to get that to get pi. So when we're trying to find the volume of a cylinder, what we need to do is just use this particular formula to help us find the area first, and then we can apply the volume formula that we looked at earlier in this lesson. So let's have a go at a couple of examples of this. Find the volume of these cylinders. So find the volume of the cylinders rounding to 2 decimal places. So we want this correct to 2 decimal places. Let's have a look at this first example. So here, this is an example of a cylinder because the top shape is a circle and it has the same cross section. And at the bottom, you're going to end up having the exact same circle as well. So here, when I'm trying to find the volume, I'm going to need to use V is equal to AH. Okay. From there, we need to find the area of the cross-section shape. The cross-section shape happens to be a circle, and so the area is just going to be pi times r squared. So here, my radius is actually 2 centimeters, so this is going to become pi times 2 squared. So this is the area formula for my circle. So here, for the circle, it's going to be pi r squared, and so for this particular case, because my radius is 2 centimeters. If you have a look at this measurement, it's from center to edge, which is what I want. I'm going to get pi times 2 squared. So that's for the area. Then I need to multiply that by the height. What's the height between those two end shapes? So here, if you have a look, that's going to be 10 centimeters. So I need to multiply this whole answer by 10. And so we can chuck this in our calculator. I'm going to go pi times 2 to the power 2, so 2 squared, times 10. Will give me 125.663. I wanted the 2 decimal places, so that's going to be 125.66. And what units is it in? Well, all these measurements were all in centimeters, so this is going to be in centimeters cubed because it's a volume. Okay, so that's how we can find the area volume of a cylinder. The volume of a cylinder can be found by just using the volume of a prism formula, but the area that we're looking at in particular is a circle. Okay, let's have a look at another example. Okay, here. Once again, we have another cylinder. So if you have a look, we've got a circle at the end of this shape. And on the other side, we would actually get another circle, which is the exact same shape here. So this is the cross-section shape is a circle. And so we need to find the area of that particular circle. So here, I'm going to write down the volume formula. V is equal to AH. Now here, this is where it's a little bit different. We need to get the radius in order to find the area of my circle. If you have a look at here, the radius is actually from the center to the edge. They don't tell me a measurement from the center to the edge. Instead, they actually tell me from edge to edge, it is 14 meters. And so what I need to do is actually I need to halve this 14 meters to find the radius. So here, the radius is going to be 14 divided by 2, which is just 7 meters. So that tells me that the radius over here is 7 meters. And so once I've done that, I can find the area, because the area is just pi r squared. So that's just pi times 7 squared. So let's put that in. Pi times 7 squared for the area of my circle. And then once again, we need to find the perpendicular height, or the height between the two circles. So that's going to be this measurement over here, 20 meters, times by 20. And so here we can chuck this all into a calculator. So shift pi times 7 squared times 20, and that gives me 3078.76. I only want that to two decimal places, so 3078.76. And we need to put a unit on this. All the measurements here were in meters, so I'm going to put this as meters cubed. So that's how we can find the volume of a cylinder. So a cylinder is just a special case of a prism where the cross-section area, cross-section shape, is a circle. And so we need to find the area of our circle before we actually go and figure out the volume. Okay, so that's it for today's lesson. Let's do a quick summary of what we talked about in today's lesson. In today's lesson, we talked about calculating the area of volumes and volume of prisms and cylinders. And so what we did was we noticed that a prism was a 3D shape where it has the same cross-section area. So here you had two ends with the exact same shape, and if we cut anywhere between the two shapes, we would have the exact same shape produced on the ends of our shape. We talked about the volume formula for a prism. V is equal to AH, where A is a cross-sectional area and H is a perpendicular height between the two cross-section shapes. And so we actually went through a few examples where we need to calculate the volume of a prism. We found the area of the cross-section shape, and then after we found the area of the cross-section shape, we multiplied by height between the two shapes. And we also talked about cylinders, where cylinders were a special case of this of a prism. A cylinder was just a prism where they had a cross-section shape of a circle, and what we had to do was we found the area of the circle, then we multiplied it by the height. So that's it for today's lesson, Year 8s. Hopefully that was helpful, and if you're not sure about anything, feel free to send me an email or message me on Google Classroom. I'm more than happy to try and answer your questions. But until next time, Year 8s, I hope you guys are staying safe wherever you are, and I'll see you in the next video. Bye!